I'm Cameron Adams. I'm a platform engineer at ITV, where I've been working for about 18 months. Before that, I was working a similar role in New Zealand, which is where I'm from. I'm going to talk to you about the story of how, for one of our products, we've been able to use Docker and Selenium to take our build pipeline down from 4 hours to 40 minutes. I'm going to show you a bit about Docker and Docker Compose and how to make your application tests be platform agnostic. And I'm also going to show you some recent Jenkins Pipeline features to run your pipeline as code. I'm going to assume a couple things. The first is that you know what Docker is. Docker is a way to build and package applications, and you can package your code and dependencies within a container. It shares the kernel on the host OS. And I'm also going to assume that you know what a build server is. It could be TeamCity, Jenkins, anything else. Basically anywhere to run your code. All right, so my project was to re-platform the infrastructure for the ITV Hub connected TV application, which is just the on-demand player for ITV content for TVs and set-top boxes. So stuff like Samsung, YouView, Amazon Fire. All the product really is it's just a web application which serves static content like JavaScript and images. The videos are served via a separate CDN. That said though, we get a good amount of load. We've got about 4.6 million views a week, which is quite nice. We use Terraform to build the infrastructure in AWS, and we use Puppet Masterless for the configuration management. So the old stack. The old stack, we had an on-premises Jenkins, which was old and slow and outdated. The test server, Selenium, was hand-built. It was set up by someone who I don't know before my time. The acceptance tests, which were independent, were run sequentially for no reason. Because. The tests were always flaky as well. And if any of the tests failed, would have to restart the whole build flow from scratch. So you can see here the time. It took 4 hours here. There's a 5 hour somewhere. It just took ages just to test some features being pushed. So what can we do? Firstly, there's no silver bullet to improving your pipeline. There's only many lead bullets. There's many ways in which we can tackle it. But there are a couple of key things. We can run these tests concurrently and get them to a point where they can be run independently and, more importantly, scalable. And we also want to target and replay any test failures. So a dev can just update one failing test. A bit about our testing framework. We use a tool called Selenium Grid. And Selenium is just a testing tool to run automated browser tests. And it can run on multiple machines with multiple browsers. So you've got the local machine running the tests. That hits a hub, which acts as a master. The node, which has Firefox installed or anything else, that hits the web application. And they feed back to the local machine. So we could build the Selenium Grid in AWS, but it would be expensive, would need multiple instances. It would be slower to provision. It would take minutes, and that's a bit annoying for scalability. It would also be harder to debug. So why don't we be cool? It's 2017. Why don't we put it in Docker? So Docker Compose. Docker Compose is a tool for defining and running multi-container Docker setups. It is all the same features of Docker, but you're able to configure it and define it via a YAML file. It has lots of other cool features as well, like environment variable interpolation, so you can easily pass in different variables to the same container to spin it up differently. It also is out-of-the-box networking as well as internal DNS, which can make things a lot easier. To spin up, you just need one command, Docker Compose up. That'll spin up a multi-container Docker environment. There's no big, long Docker command with lots of linking or anything else. It's all spun up concurrently, and again, it's all inside one network, so it's very easy to use. We can also scale the containers much easier with one command. For example, if we want more Chrome nodes, we can just use one command here, and that'll spin them up or scale them down. All right, so that's our Selenium grid sorted. For our tests, we only need Chrome. We still have to worry about the application, the stub data, and all the test scripts. So we're still stuck at one test per machine. So why don't we do the next thing and put them in a container? Cool, that was simple. You want the KISS philosophy, and you want one process per container. These containers are all built on demand and uploaded to a private Artifactory. We build our test suite each time the tests have changed, so that's separate to the app repository. We've also got an Nginx proxy as well for Google Analytics capturing, which is quite neat. And again, it all exists in a private network. And this doesn't just work for my setup, this could work for yours. So if you've got microservices, and say you want to test microservice A, you can do that, spin up a test server, and have your other microservice dependencies set up as well. And because you can pass in environment variables, you could just pass in a certain version to pin against your tests. And you can still talk to the outside world as well, map a port, stuff like that. Great, so that's a huge win, right? We've now been able to make our tests run independently of each other. It'll spin up way faster. The Selenium grid now takes 5 seconds to spin up. It's cheaper as well. It's all on the same instance. It's platform agnostic. That's a big key. So it can run on a CI server, it can run on your local machine, it can run on my local machine. And because of that, we've removed the it worked locally excuse. The developers can now run it all themselves. And because of that, we have way more developer ownership. Because they can run and manipulate the tests, they know what's going on, they buy into things a lot more. So now to run multiple tests, it looks something like this. We've got one C4 2XL large instance. We can run multiple tests per instance, and all we need to pass in is just the feature flag. Also, one thing to note that my theory on AWS instances is that it's fine just to go larger because of the cost for a large instance size is always better than a developer just twiddling their thumbs. Okay, cool. So now how do we run these tests at scale? A bit about our CI infrastructure. Who uses Jenkins? Cool. You should benefit then. So we use Jenkins at ITV as well. We have one per product. We use Terraform to provision it, and we use Puppet as well to provision it and to set up all the jobs. We have an ephemeral master, which we can restart anytime we want, recycle. And we also have slaves, which live in an auto-scaling group. They're turned off overnight, and in the morning we just spin up one. So Jenkins recently released a tool called the Jenkins file, and that has a lot of pipeline features. What this does is it allows you to run a pipeline as code. It's just Groovy code, and you can do lots of cool things. So in our case, we use it as an orchestrator to run other jobs. You can treat jobs as objects, and from there you can get details, manipulate them, stuff like that. We can run jobs concurrently, and it also has a replay feature as well, which is quite handy. And because it's a code, it's a script, it lives in the app repository, the developers can now own that, they can play around with it, test stuff. So here we've got an example. We've got a flag in the Faust. We're running a job here, we're getting some details, we're writing them in console, stuff like that. We can shell out. This is the concurrency bit. We set up a stage here, which will give you a nice view, which I'll show in the next slide. We're doing some stuff for ports, to free up ports. We can pass in any other variables. We also can catch failed jobs and then just output it. So it's code, right? But for your Jenkins. So yeah, we've got the stage view here. In the build candidate bit is where we spin up the rest of the slaves, and it will just run through. The slaves take about 10 minutes, and then we leave the Jenkins slaves on for the rest of the day. the other great thing about this is that we can replay our pipeline, and we can change things just for a once-only run and not change the job config permanently. For example, say if any of these test jobs fail, the developer can just replay, delete the test, stuff like that. Jenkins does have a paid feature for this, so that you can set up checkpoints and then it will restart automatically. But we use the free one, so we're stuck with that. So now we're at a point where we can scale massively. We've got one Jenkins pipeline, which spin up 6 slaves. In those, they spin up 4 Docker Compose networks each. That means you've got 24 Docker networks, and inside there you've got 144 containers. So and also when you do this, you want to keep the idea of the Unix philosophy of do one thing and do it well. If this was all like hard coded and there were lots of like weird dependencies and stuff like that, you'd never be able to do this. So yeah, here's the container, compose, slave, and the pipeline. And also, because they're all independent of each other, when the pipeline will rerun, like this test here might run on here, but because it's all independent of each other, it's fine. All right, so what does that give us? Well, now our CI is now 6 times faster. What used to take 4 minutes, now 4 hours, now takes about 40 minutes. That's from commit to deployment. Rate of releases went from 4 to about 12 per month, which is a big win. We now have total ownership of our CI, so the devs can run all these tests locally, and they can now own their pipeline as well. It's platform agnostic, and it's scalable. This work is now a force multiplier, so it's not just my time which is being saved, it's a whole team. So a team of 6, that's 6 by 3 hours, that's 3 working days each time we want to do a run. And even though I showed you the Jenkins Pipeline features, which most of you could use, you could still use this on TeamCity or anything else, the Docker Compose stuff. So some lessons I learned from this project. With your developers, trust but verify. Because they might have a misunderstanding of how the platform works, what they tell you may differ from reality. Yeah, that also means you should iterate a lot as well. The other thing as well is cache your dependencies. When you try and make things scale like this, it's stability over everything. Docker tags don't work like Git commits and can be overwritten. Things like Google Chrome, their packages get forgotten in the internet quite quickly. You've also got the 80-20 rule. So do the amount of work for the maximum amount of impact. I mean, there's a lot of things I could do and I'd like to do to speed up this pipeline more. I could probably get it to like 10 minutes. But so far the devs are happy with 40 minutes. When they get annoyed with that, which they will at some point, then they can hit me up and we can improve it further, but we need their buy-in. Cool. So I've shown you how to use Docker and Docker Compose to make your tests be platform agnostic. And I've also shown you some recent Jenkins Pipeline features to run your pipeline as code. And one thing to remember as well when you do this is there's no silver bullet. You need many lead bullets. There's no quick win here. There's lots of small wins which will multiply, which will add up to be a big thing.